Holiday and Resnick, Chapter 7, Problem 24. A horizontal force, Fa of 20 newtons, is applied to a 3.0 kilogram psychology book as the book slides a distance of 5 meters up a frictionless ramp angle 30 degrees. During this displacement, what is the net work done on the book by Fa, the gravitational force on the book, and the normal force on the book? If the book has zero kinetic energy at the start of the displacement, what is the speed at the end of the displacement? Well, we'll start with a free body diagram. We have the ramp. We have the book. We have F of A. And we know this is going to be F of A cosine theta. This is going to be F of A sine theta. And we know we're going to have a force in this direction, which is mg sine theta. Theta here. We're going to have the gravitational force. And we'll start our normal force. Normal. And here we're going to have mg cosine theta for this leg of our normal force. And this is just mg sine theta, same force, gravitational force. Okay, we know that mg sine theta, let's take a direction for our we're going to say moving up, the incline is positive direction. So this will be minus. We got mg sine theta plus f of a cosine theta. It's just going to equal our total force in the x direction. So we can solve A now. A says during this displacement, what is the net work done on the book by F of A? We know that it's going to slide up the ramp a distance of 0.5 meters. So work is equal to force times distance, which is going to equal, the book weighs 3 kilograms, 3 times gravity, 9.8, times the sine of 30 degrees, which is given to us, 30 degrees, times the sine 30 degrees, and this is minus, plus Fa, which is 20 newtons. That's given to us, 20 newtons times the cosine of 30 degrees times the distance, which is 0.5 meters, and that's going to equal 1.3 newtons, part A. The gravitational work is just 3.98 times the sine of 30. Now, it also asks for the normal force. So, the normal, this is still part of A, is going to be N minus mg cosine theta minus, go over here to this portion, FA sine theta is going to equal MA. And we know it doesn't accelerate off of the incline, so that's equal to 0. So the normal force is going to equal mg cosine theta plus FA sine theta, which is equal 3 times 9.8 times the cosine of 30 degrees plus, now FA is given to us as 20 newtons, 20 times the sine of 30 degrees, and this is going to equal, which is, that'll end up being 35 newtons for the normal force. Now B, it just wants to know what is the speed of the block when it goes through a displacement of the 5 meters. So we can just take the work and set it to 1/2 mv squared. We can do it because we're working with conservative forces and we have no frictional force, so we can set these two. And so this will go to v squared is equal to 2 times the work divided by the mass, and this will go to V equals the square root of 2 times 1.3 joules divided by the mass, which is 3.0 kilograms. So V is going to equal, it's going to give you 0.93 meters per second. So that's part B. Now notice that I said when you multiply force times distance, you get joules. I put newtons in there, so that is definitely wrong. So that is joules. Okay.